All right, so what I'm going to be teaching you is a brand new thing. It's very simple though. It has to do with remember last year you learned so, ka, toa, and this was sine was equal to opposite over hypotenuse. Cosine was equal to adjacent over hypotenuse, and tangent was equal to opposite over adjacent. Well, there's actually 6 trig ratios. These are only 3. The other 3 are called cosecant, secant, and cotangent. And all it is the reciprocal is h over o, h over a, and o over a. Or you can think of it like this. Cosecant is the reciprocal of sine, so it's 1 over sine, which is h over o. Secant is the reciprocal of cosine, which is 1 over cosine, or h over a. Cotangent is the reciprocal of tangent, which is 1 over tangent. So if you did this mathematically, you're going to get o over a. I'm sorry, this is over o. Let me do this in a different one. A over o. So these are the 6 trig functions. These 3 buttons you will find in your calculator. If you're looking for these 3 buttons, cosecant, secant, and cotangent, you will not find them. But mathematically, the way that you do it is you just do the reciprocal of sine, or h over o. Secant is the reciprocal of cosine, which is h over a. And cotangent is the reciprocal of tangent, which is 1 over tangent, or a over o. Those are the 3 new trig functions. So the worksheet that you're going to be doing has to do with these 3 trig functions. But what I'm going to be doing is these are the 3 trig functions that are new. Since this is a STEM class, you can kind of connect the pieces with how to find like the 6 trig functions. You're going to have a worksheet. You have the answers to that worksheet. But what I'm going to do is I'm going to go over the test right now. I'm going to go through each question, starting off with question number 1. It says, solve for triangle ABC if angle A is 58 degrees, angle B is 52 degrees, and side B is 62. All right, first I'm going to solve for A, side A. So I'm going to use law of sines. Sine 58 over side A equals sine 52 over 62. Now, I'm not going to do all this mathematically, but what I'm going to do is just set it up and then walk you through it and then move on to the next one just for the sake of time. So I'm going to cross multiply, and I'm going to get A times sine 52 equals 62 times sine 58. Divide both sides by sine of 52, and that's what A is. Once you have A, you can use law of sines again to find this side, because you know this angle, 180 minus these 2 finds this angle. Then you can use law of sines for that. Anyways, the answer to letter choice, or number 1, is C. Okay. Number 2. Find the value of inverse sine 1/2. What that's asking is, what angle gives you opposite over hypotenuse of 1/2? It's going to be a 30, 60, 90. So watch this. 30, 60, 90 degrees. This is 1, this is 1/2, and this is root 3 over 2. What angle gives you opposite over hypotenuse to give you 1/2, which is 30? Your answer is 30 degrees, which is letter choice A. Or if you just have a calculator, you can just plug this in. Inverse sine 1 divided by 2 is going to spit you out 30 degrees, which is letter choice A. Okay, for number 3, it's just a SOHCAHTOA. From 38, you have your opposite and hypotenuse, so it's just sine 38 equals x over 10, cross multiply. 10 times sine of 38 is what x is. And letter choice C is the answer for number 3. All right. Going on to number 4. Convert 5/6 pi to degrees. Remember, 5/6 pi times 180 over pi. This is the conversion that you multiply when you're changing it to degrees. This goes away, the pi's go away. 6 and 180 becomes 1, and 30 to give you 150, which is letter choice D. Okay, for number 5. Evaluate cosine of 7 pi over 4 without using a calculator. So what I'm going to do is I'm going to go 7 pi over 4 times, I'm going to convert this to, this is number 5. I'm going to convert this to degrees first. You don't need to do this, but I think it's easier if this is still kind of confusing you. All right. So I'm just going to go, instead of reducing, I'm just going to use my calculator. 180 times 7 divided by 4 is going to give me cosine of 315. So if I were to draw out 315, it would be right here. This is 315 degrees, giving me a reference angle, because it's always to the x-axis, of 45 degrees. So if I were to draw out this triangle, it doesn't look like, but this should be a 45, 45, 90-degree triangle. This side is root 2 over 2. This side is negative root 2 over 2. And this is theta. So cosine is adjacent over hypotenuse, root 2 over 2, which is letter choice C for number 5. All right, for number 6 is the exact same thing as number 1, but it's done a little differently. So for number 6, I'm going to draw out A, B, C, and angle A is 53. Side B is 59, and side C is 56. I have to solve for this. So I'm going to find side A. I'm going to use law of cosines. If I use law of cosines, which is it's c squared equals a squared plus b squared minus parentheses 2ab cosine of angle C. Now I told you in your notes, whatever angle they have, make that your angle C. This is your side C. So the mathematical formula is c squared equals 56 squared plus 59 squared minus, or 59 and 56 squared, it doesn't matter, minus 2 times 56 times 59 times cosine of 53. Now, I'm not going to do this on the calculator, but you could just do this on your calculator. You're going to get c squared equals some number. Once you have that number, you actually square root your answer to figure out what this number is. Once you know this number, you can use law of sines. Sine 53 over whatever this side is equals sine x over 56. Cross multiply and then do inverse to figure out one of the angles. And then you can do 180 minus these two to find your last angle. Anyways, number 6, your answer is A. Okay, going on to number 7. convert 150 to radians. So I'm going to get rid of the zeros. So I have 15 pi over 18. Divide both by 3 to get, what is it? 5 over 6 pi, which is letter choice B for number 7. Super simple. That was easy. All right, number 8 is another triangle question. So I'm going to draw this triangle A, B, C. With side B of 2, side C is 4, and angle A is 118. And it wants me to find this side, which is the exact same way as I did this. 4 squared plus 2 squared minus 2 times 4 times 2 times cosine of 118, and then square root your answer. Next one, number 9. All right, for number 9, without using a calculator, what angle gives you a negative root 3 over 2? So let's figure out what angle gives you inverse sine of, let's just do, first off, root 3 over 2. Let's figure out what angle gives us a negative root 3 over 2. Here's your 30, 60, and 90. This is root 3 over 2. So I know that it's going to be 60 degrees, gives me opposite over hypotenuse because it's sine. So 60 degrees is my answer, but that's incorrect because this is your reference angle. So you have to, if I were to draw, this is 60, this is 60, and here's my right triangle. This is root 3 over 2. This is negative root 3 over 2. And then let's do 2 reference angles here. This is 60. This is 60. This is root 3 over 2 because it's up, but this is negative root 3 over 2. So there's actually 2 answers for the opposite over hypotenuse to give you a negative root 3 over 2. One of these is what angle gives you a 60-degree reference angle, which is going to be 240, or what angle gives you a reference angle of 60 degrees here, which is 320. Neither one of those are on it, but look at letter choice D. If you do negative pi over 3, that's negative 60 degrees, which is boom, right here, D. Super simple. All right, for number 10, it's the exact same question. I'm not going to do that one again. It's the exact same question as number 8 and number 6. So number 11 and 12, rewrite each degree in radians and each radian in degrees. Remember, when you're converting theta to radians, you multiply the degree times pi over 180. When you're converting theta, when it's in radians to degrees, you multiply it by 180 over pi. This is to change it to radians. This is to change it to degrees. So number 13, number 11 is pi over 10. When you do the math, I'm not going to do the math. It's super simple. I'm just going to do this for saving time. And this is a negative 110 because it's original negative 11 pi over 18. This is 11 and 12. Okay, for number 13, whenever the bases are the same, you can multiply or apply the properties of logs. So I'm going to say convert this to natural log 3x plus 1. Dividing means it's a fraction of x plus 5 equals 0. Now, how do I get rid of this natural log? I change it to e raised to the 0th power equals 3x plus 1 over x plus 5. Remember, base exponent, what it equals. Now, e to the 0th power is 1. 1 over 1 equals 3x plus 1 over x plus 5. There's your proportion. Super simple. Number 13, your answer is 2. Okay? Now, number 14. What I'm going to do for number 14 is I am going to move the one side equal to 0. Oh, let's do this first. Let's do log base 3 y squared equals, remember when you add with the same bases, you multiply. So it's going to be log base 3 4y plus 32, because I multiplied 4 times y plus 8. Now, these two are the same bases, so it's telling you log y squared of base 3 is the same value as this. So technically, these have to be the same value. Y squared has to equal 4y plus 32, and here's your equation. Move these over, y squared minus 4y minus 32 equals 0, and you get y minus 8 times y plus 4. When you solve this, you get y equals positive 8 and y equals negative 4, but one of these is extraneous because when you plug it back into the original equation, one of these is going to give you a negative log. This is extraneous. This is the only one that you can have. Some people put both of these answers. I couldn't give you credit because I'm testing you whether you understand why it was extraneous or not. So 8 is your only answer for number 14. Okay, coming on to 15. So what I'm going to do is I'm going to change, this is 10 to the x squared plus 1 equals, I'm going to change this base 10 to 5. This is number 15. Therefore, the bases are the same. The exponent, x squared plus 1, has to be the same as well. Now, I could subtract 1 to get x squared equals 4, and I get plus and minus 2 when I square root it. That's my answer. Super simple. Change it to the base, change both of them to base 10. 10 to the 5th is still 100 grand. So I haven't done anything with the value. I just made it so I can set the exponents equal to each other. Okay, number 16. Find the reference angle for pi over 3. So pi over 3 is coming up 60 degrees. So it's back down 60 degrees. Most people left it as degrees, which is fine, or 60 degrees is pi over 3. Either one of those answers works for me. And same exact question for 17. Find the reference angle for negative pi over 3, which is negative 60 degrees. So that means if you go back 60 degrees, that's your reference angle. Or as a radian, it's pi over 3. So 60 degrees or pi over 3. So 16 and 17 are both 60 degrees or pi over 3. Some people put negative 60 degrees. That's incorrect because a reference radian or reference degree is always a positive answer. All right. Find the inverse function of y equals log x of base 8. Remember, you have to flip the x and the y to solve for the inverse. And then, how do you get rid of a log after you flip it? After you flip the x and the y, base exponent, what it equals. Base exponent, what it equals. There it is. There's your inverse, y equals 8 to the x. Okay, now for number 19, you had to condense. For number 19, you had to shrink. You had to shove it all together. So I'm going to say log 3 base 4 plus log 2 to the third base 4. And then when you add, you multiply. 2 to the third is 8. 3 times 8 is 24 base 4, and you just leave it. That's it. What's a reference angle for 220 degrees? That is number 20. Well, let's figure out where we are. Here's 180. If I go 220 degrees, I'm right here. That means I have to go 40 degrees back. There it is. There's my reference angle. How simple is that? Very, very simple. Now, number 20. I'm sorry, that was 20. 21. Find the reference angle. It's the same thing as this for negative 309. So negative 309 is about right here. Boom. Here's negative 309. That means you have 51 degrees to get to the x-axis. There's your reference angle for 21. Okay, so 22, expand. Natural log 2y minus natural log of x. This is what some people left it as, but remember, this is multiplication. So this becomes natural log, this right here becomes natural log of 2 plus natural log of y minus natural log of x, because whenever you multiply, it's the same as adding. Okay. Number 23. Okay, for number 23, what you're going to do is on a unit circle with a point -1 and up root 3. Boop, there's your triangle. Find cosine of theta. Okay, well, let's look. I'm going to go -1. I'm going to go root 3. So I got to find cosine, which is this side right here. So a squared, -1 squared is 1, plus b squared, root 3 squared is 3, equals c squared. 4 equals c squared, square root it to get 2. All right, here we go. What's cosine of this? -1/2. That is your answer. That's it. Okay, and then the last two. For number 25, it is pretty simple because it's already set forward. So look, what I'm going to do for 25 is I'm going to do this. I'll do 25 first because 24 is a little more difficult. I'm going to say x and y, and I'm going to go -2, -1, 0, 1, 2. And then I can kind of guesstimate how it's going to look. Let's say I add a 10 into here. Okay, so this is y equals e to the -2nd is going to give me, remember, e is 2.71 something. So it's going to give me 1 over 2.71. 1 over 2.71. I don't know. Let's do that. You can actually just plug it in. Let's just say e raised to the -2. It's going to, e raised to the -2 is going to give me 0.13. If I plug it in 1 here, I have e raised to the -1st is going to give me 0.37. E raised to the 0th power is going to give me 1. E raised to the 1st is 2.71. and no, 718, whatever. And then I'm going to go e raised to the second is going to give me 7.3. And if I do e raised to the 10th, it's going to give me a big number. All right, and then if I were just to graph this, say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Negative 2 and 0.3 was like right here. Negative 1 and 0.37 was a little bigger. 0 and 1, and then watch what happens. 1, and I get 2.71, which is almost 3. Then I have 2 and 7 point something. 2 and 7 point something, which is way up here. And then let's say I have 10. I'm at a big, big number up here. So this is what it's going to look like. Something like this. Your asymptote right here is going to be your x-axis. I did not give you credit if you just grabbed this kind of ugly and just went like this. Because you can't have a negative y value. There's no way you can plug in a number in here to get a negative y value. This does not exist. Your asymptote is the x-axis. People that did this, I did not give you credit for it. Okay. Now what I'm going to do is I'm going to do the exact same thing, but for 24.